Today we're going to be looking at the topic of memory arrays. We've already talked about how you can declare variables in computer science and that those variables are locations on the computer's memory that are very similar to office mailboxes or pigeonholes, and each one of them is named so we know which one is which, and within them we can actually store things like numbers or names that we then go and access later. Well, arrays are kind of interesting because they're actually a way of setting aside a whole collection of mailboxes that, if you wish, are side by side, and we want to have them all store very similar items. And they're all going to be stored under one large name. And then within that grouping, maybe there's like a grouping of 5 of them, you can actually refer individually to each one by some sort of numeric value. Like you can say, oh, well, let's go and look at the second one, or let's go and look at the fourth one. But they're all going to have some sort of common name to them. In coding, we're going to actually declare the variable array like this. So this is going to declare space in memory for 5 different test scores, but they're all going to basically have the same name. They're going to be called test scores. And in square brackets at the end, that lets us know that we need 5 of them. Now within that grouping of 5 mailboxes of 5 memory locations, all big enough to store an integer, they've kind of got this little numeric index that you can use to refer to them. And you might think, well, the first one would be called number 1, and then the last one would be called number 5. But in computer programming, the first one is actually the 0th one, and then the second one is number 1, and then the third one is number 2. So if you actually have 5 of them in your array, the last one is the 4th one. And that's a very important issue that you have to be very careful about when you're actually doing your coding. When it's time to actually assign the variables, maybe these are the 5 test scores that you need to actually record. Perhaps the very first one is 95, so that's going to go into the 0th location. And maybe the last one is 64. And by the time the computer executes these 5 lines of code, it'll look something like this in memory. The whole collection of mailboxes, of all 5 of them, is called test scores. But within that grouping of 5, there are 5 different spots, and we can refer to them numerically as the 0th one, the 1st, and so on, all the way down to the very last one, which is the 4th one. Now, you could, if you really wanted to, avoid the use of arrays. You could say, well, I'd rather not do that. I'd rather just have a whole bunch of different names. Just test score 1, test score 2, all the way out to test score 5. It absolutely does work. But what we're going to see next class is that you can actually get the computer to start cycling through on its own, keeping track in some sort of loop of where it's at, and it will automatically iterate its way through the various memory locations that you've got. So we can automate the process of asking 5 different test scores perhaps, and we can get a loop of code to actually do all of that for us. So if all of a sudden somebody says, well, I need to actually input 50 test scores, a quick change in your coding and everything's ready to go. Now, there's actually a need sometimes to think of those memory locations as being like a grid, maybe a 2-dimensional array, sometimes even a 3-dimensional array. Here's a good example of when you might need a 2-dimensional array. Imagine you've got 3 different students, and each one of these 3 students has actually written 4 tests, and you want to record all of those test scores. So obviously there are actually 12 different test scores that you have to record. And if you do this as an array, we can have one common name, just test scores. And we can tell the computer that actually there are 12 spots, and they're arranged in 3 rows of 4 columns. And if you wanted to actually declare that in memory, it would look something like this. So this says, hey, we need some integers. They're all going to be called test scores, and they're going to be grouped in this arrangement. Kind of just a nice little rectangular arrangement, 3 up and down, and then 4 across. Now, if you wanted to actually talk about this one in particular, maybe you wanted to assign this one the value of 67. At first glance, you might look and go, oh, okay, well, that's student number 2, and it's test score number 4, and you might try this out. You might say, okay, test scores in row 2, column 4 needs to be 67. But it turns out that doesn't work. In fact, you'll actually get an error when the code tries to run. The trouble is with the way that we actually number them. We always start with the 0th one. So the student you're looking at is not the second student, but it's actually the first. And the test that you're looking at is not the 4th, but it's actually the 3rd. So you would actually have to change your code to look like this. This would be the test score for the first student, not the 0th student, and it would be the 3rd test. So that's actually the 4th one in the list because it starts off with the 0th test. Likewise, if you wanted to talk about that very first score, that one that's 55, that one is actually test score 0, 0, and they're both in individual square brackets. And that way it knows, okay, it's the very first student and it's the very first test, and we can assign it a value of 55. So right now you might be kind of looking at it going, oh, is this really going to save me some time to be able to declare all those memory locations at once? And the answer is, yeah, once we've seen how to do loops, this will be a massive time saver to be able to have all of those memory locations grouped together under one name that we can then just numerically refer to which one we want to talk about in the group. And that'll really pay off when we start to look at loops next day.